Okay, geometry. We're going to do more with proofs today. But today, instead of doing the algebra proofs, we're going to be working on proofs involving segments and lines. So this takes a little bit more thinking about, but what I want you to remember is what I have up above here, is those different properties from equality that I said we don't use in algebra very much. The reflexive property, the transitive property, the symmetry property, or yes. Those, we don't use that often in algebra, but we do use those quite a bit in geometry because we'll say something will equal itself so that we can add it to both sides of an equation. We can do that. So we have to be able to do the algebra part. But now we're not going to have numbers in just a single variable. We're going to have parts of segments or parts of angles and that kind of stuff running around. So be aware of that. But let's get started here. Okay, so we do have this reflexive, symmetric, and transitive properties. And as I said, they do hold true for segments and angles. I told you that in the video itself for this section. Now, as a reminder, there are some properties here that we need to be aware of. We have the postulate 2.8, the ruler postulate. This is basically we can give a length to everything. And the segment addition postulate, it's a big one. The segment addition postulate is definitely something that you want to get into your head. Anytime I'm adding segments, pieces of segments to make a bigger segment, I'm going to use the segment addition postulate. And then theorem 2.2, huge. 4 segments. Reflexive property, a segment will be congruent to itself. Symmetric property, if one segment is congruent to a second segment, then I can swap the orders around. Transitive property, again, big. If I have segment AB is congruent to segment CD and CD is congruent to segment EF, then AB has to be congruent to EF. So those are the big properties that we're going to use today. We're going to get a part that looks like this, and it's going to tell us just to justify the property of equality or the property of congruence or a postulate that would state that this is true. Well, now the first one just says QA equals QA. That is the reflexive property of equality, not of congruence because there's no congruent marks. Now, as far as I'm concerned, we could just say reflexive property. We don't have to say reflexive property of equality. But technically, that's what you should say. Number 2, I got segment AB is congruent to segment BC, and segment BC is congruent to segment EF. This is right here at the bottom of our list there. That is the transitive property of congruence. That's part of theorem 2.2. Part of theorem 2.2. Okay, the third one. If Q is between P and R, and PR equals PQ, then PR equals PQ plus QR. That looks a heck of a lot like the segment addition postulate. Now that's a postulate, not a property. Okay, make sure you're aware of that. Now if you look at number 4, if AB plus BC equals EF plus FG, and AB plus BC equals AC, then EF plus FG equals AC. Now we can fit this under 2 ways. We can put this underneath substitution, because I've replaced the AB with an AC in this original equation. I stuck it in there. I could also call it transitive, because I did go from this AB to the EF, the AG, and the AB to the other. Either one of those in this case works because we're putting it in place of on the side of the equal sign. So either one of those would work in this case, but it's not always going to be true that it could be either one. Typically speaking, if it's transitive, it can be considered substitution. Okay, next set. Then we actually have to do some proofs. Here we just have to complete the table. So it's a lot like what we were just doing. We just have to figure out what the statement is or what the reason for it is. Well, this very first one here, number 1, we're given that BC equals DC. We have to prove that AB plus DE equals AC. So I'm looking at this picture, and I know that BC equals DE. So I'm going to say that's given because that's what's listed here in the given. 99% of the time, your very first statement is going to be your given information. Well, now here we're told that I have the segment addition postulate. It means I need to have 2 parts that I can add together to equal a segment. Well, the only things I can add together are this part here. I got the AB and the BC equaling AC. So AB plus BC equals AC. The two smaller segments, AB and BC, equals that AC. And then finally, we got AB plus DE equals AC. Well, now notice, here's a kind of a cool thing. Let me switch to a highlighter with my... I have BC equals DE, and notice here, my BC and my DE have been switched. I put DE in place of BC. So this is our substitution property. And that is done. Nice little proof there. Let's look at one that's a little bit bigger. So I got Q is between P and R is between Q and S, and that PR equals QS. Big information there. So now we're given that Q is between P and R, and that's given information. Step B says PQ plus QR equals PR. That's addition. I'm adding things. This is the segment addition postulate. Told you to beware of that one. Now we're told that R is between Q and S. Well, that was written up here again. So this is, again, given information. Now it wants us to use the segment addition postulate. That means I've got to use this R, the Q, and the S to add something up. So that would tell me that QR plus RS equals QS. Now I've got PR equals RS. Well, why is PR equal to RS? Sorry, PR equals QS. I read that wrong. PR equals QS is right up here in our set of information. It's underneath the given. Well, now since PR equals QS and PQ plus QR is the PR, I'm going to place that in place of the PR, and our QR plus RS is on the other side. We just did some substitution in our problem for part E. I just replaced with the PR equal and the QS equal. Well, now notice what we're doing here. We're going to take away a QR from both sides. The only way I can take away a QR from both sides is the subtraction property. And now we're listening to that substitution, which must mean I'm rewriting things. And I think what it's going to be is the fact that here, these two QRs are going to cancel. And on the bottom, the QRs are going to cancel. And I'm left with the PQ plus, sorry, not plus, PQ equals RS, which is what we were trying to prove. So that one's done. So it's semi-nice when they give us something to prove and they fill in the table. We don't have to think everything through. We just got to kind of fill out what their thoughts were. Now, what we can have is we might have a theorem like this where we have to write a two-column proof for this particular problem. I'm given that segment AB is congruent to segment DE, and segment BC is congruent to segment EF, and I'm supposed to prove that segment AC is congruent to segment DF. Okay? I've set up my table here. I went 5 steps listed on there. It might take more than that. It might take less. I don't know. I just set it up. So here we go. I'm going to start with the given information that AB is congruent to DE, and that BC is congruent to EF. That's our given information. So I'm going to put that down. Now, what does that mean for them to be congruent? Well, that means that AB has to be equal to DE. And that means that BC has to be equal to EF. Why does it mean that? That is the definition of congruent segments. They have to be the same length. Now, step 3, I've got to get somehow all the way up to AC and DF is what I got to get to. So I'm going to kind of work on these a little bit, but what I know is when I look at this, I can see that AB plus BC is equal to AC. And I can see that DE plus EF is equal to DF. When I look here at the pictures, I got the 2 segments listed there. So if I take the 2 smaller segments and add them up, I got to get the 2 bigger segments. So I have that set up like that. So that is the segment addition postulate. Now notice all three of these cases, I have listed both statements with the same reason under both of them. So I'm putting two statements for each step here. Now I could have put them on each as separate ones. So now what can I do from now? I'm trying to get that AC equals DF. So AB plus BC equals AC. Well, notice here, kind of a neat deal, I've got BC is equal to EF. And I have AB is equal to DE. Well, since these two things are equal to each other, I could add them together. I could take AB and add BC and let that equal DE plus EF. I'm just going to take this first group and add this second group. Since they're equal, I can add them to both sides. That is just the addition property. I'm adding the same amount to both sides since they were equal. Well, now if I look carefully, this AB plus BC was written up here as AB plus BC. It was AC. And if I look also, I got DE plus EF, DE plus EF. That's DF. So now I'm going to replace the AB plus BC and the DE plus EF with these other two. So that is just substitution. And that's a property again. Now, I'm not done because I had to prove that they were congruent. So my next statement here, I have to do one more, is I'm going to say segment AC is congruent to segment DF. And our reason for it, again, goes back to the definition of congruent segments. So what had to happen for this particular proof is that we had to set it up in such a way we had to get out of being congruent, do the work in the equal signs, and then go back to being congruent. And that happens from time to time. Now, I really should clean out my junk out of my theorem. Not that junk. That's actually information. So get these all out of there. And that would be my theorem, or my proof right there, that that is all true. I should do it on this side as well. So that way it's all nice and true. I got statements. I have a reason for each statement that I have on there. I have valid reasonings for doing it because my reasons are definitions, properties, or theorems or postulates along those lines. So that's what you're doing on the assignment on, what is it, page 104, the 18 to 23. Okay, good luck on it.